Hello, everybody. Here's what we're going to do. We're on, in your packet, go to section 7.7, products and quotients of rational expressions. We're going to do a few of these together. This is when you have rational expressions um, and you're multiplying or dividing. So rational expressions are just expressions with ratios, fractions. And what we want to do is we want to do the multiplication or division. Some of these are multiply, some of these are divide. And then we want to do that operation, simplify everything, and state any restrictions on the variables for our domain. Okay, so I'm going to do a few of them together, and I'll finish the rest of this worksheet so you can work through them on your own, and I'll post the answer sheet. But I think I want to do number 1, number 2, number 4, number 6, and then we'll go down. We'll do maybe a couple of these on the bottom. Okay, feel free to fast forward through this, or if you want to just try them on your own before I go through them all together. Okay, but what we're going to do here, 2x to the fourth, I'll zoom in a little bit on that one, over 10y squared, over 5y cubed, over 4x cubed. So first of all, any value of x or y that makes any denominator 0 at any point, because you can't divide by 0. So if y is 0, you're going to divide by 0. If x is 0, you're going to divide by 0. So we're going to write out our restrictions. X cannot equal 0, and y cannot equal 0. So there's our restrictions. Okay. Next, we can reduce the 2 and the 10. Let's make that a 1 and a 5. And actually, we're multiplying. So when you multiply fractions, you multiply the tops, you multiply the bottoms. There's a 5 on the top and a 5 on the bottom. We can cancel those 5s. Okay, so we're going to get x to the fourth times y cubed on the top. And on the bottom, we're going to get y squared x, 4y squared x cubed. Okay, and then we can see that we have x cubed on the bottom next to the fourth on the top. So there's one more x on the top than on the bottom. So these three are going to cancel with 3 from the top. So we get an x. The y's, 2 of the y's are going to cancel. Y squared cancels with a y squared here, and we're left with one more y on the top, and then we get a 4 on the bottom. So right there, that's our answer to this one. Okay, that's a pretty straightforward example. For the rest of the problems, we're going to have to do some factoring first. So if you're ever able to do factoring first, you always want to do any factoring first that you can do. Let me see if I can zoom in this a little bit out of practice in using this camera because I haven't done much this year. Okay, so this one right here, we're going to factor everything first. So x squared minus 5x plus 6 factors into x minus 2, x minus 3. We're multiplying, so we actually can simply multiply this times this across the top. And we get x squared plus 7x plus 6 factors into x plus 6 times x plus 1. On the bottom, x squared plus 5x minus 6 factors into x plus 6, x minus 1. And then x squared minus x minus 6 factors into x minus 3 times x plus 2. Okay, so right now we can see what some of our restrictions are going to be. X cannot equal, let's put these in order, negative 6, negative 2, positive 1, and positive 3. So there's our restrictions. Our domain would be all values of x outside of other than these values. You could do interval notation if you want, but right now we're just stating the restrictions. Okay, now the x plus 6 and the x plus 6 can cancel. Anything else? The x minus 3 and x minus 3 cancel. Then we get x minus 2, x plus 1 divided by x minus 1, x plus 2. Now, it's really important that you determine these restrictions before you do any canceling. If you waited till you're done to figure out your restrictions, the only restrictions, it would look like the only restrictions we had were positive 1 and negative 2. But that would be incorrect because you'd be missing the restrictions of when x is positive 3 and when x is negative 6. Because when they cancel, you kind of forget that information. Okay? Let's go down to the next one. Now we have one where we're dividing. And be careful here. I always want to factor first, even before we divide. Because remember, when you divide fractions, you're going to leave the first fraction alone, and you turn the divide into multiply, and you flip the second fraction. Okay? We're not going to do that just yet, because when we're figuring out our restrictions, we have to make sure we figure out all restrictions. So x squared plus 5x plus 6 factors into x plus 2 and x plus 3. X cubed plus 8, that's the sum of two cubes, factors into x plus 2 times x squared minus 4x plus 4. And we have divided by, this is going to be x plus 3, x plus 1, divided by, and this factors into x plus 2 and x plus 1. Okay. So let's figure out our restrictions. X cannot be negative 2, negative 2 again, negative 1, and I believe this, I did that wrong. Sorry about that. That should be, when we factor the difference of two cubes, just as a quick reminder, that's x cubed plus 2 cubed. It's going to factor into x plus 2 times x squared, and then minus 2x, not 4x, and then plus 4. Okay. Now this thing, I believe there's no value of x that makes that 0. If you want, you can double check that. I'm just going to go off to a separate sheet of paper. If we tried to set x squared minus 2x plus 4 equal to 0 and find out any values of x that would make that entire thing, this entire thing, 0, we would get, we'd use the quadratic formula, opposite of b, plus or minus square root b squared minus 4 times a times c, minus 16 over 2a. Right there we can see there's going to be no real answers because we get square root of negative 12. So there's no real values of x that would make this quantity 0. Okay, so these are our only two restrictions. Okay, so now what we can do, we can actually cancel these two right now. We can cancel these two right now. Okay, and then what we have is x plus 3 divided by x squared minus 2x plus 4. And then instead of dividing, we're going to multiply. But when we multiply, we flip this fraction. So that's going to be an x plus 2. And then here we've got an x plus 3. And now we've got an additional value of x that's in our restriction. Because really we were dividing by this value. And if anything here makes the numerator 0, well, we're dividing by 0. And we can see it a little bit better here. So when x is negative 3 is another value that we have to restrict, that we have to remove from our domain. But now we can cancel the x plus 3's, and we're going to get an x plus 2 on the top, and we get x squared minus 2x plus 4 on the bottom. Okay. And let's go on to the next one. I thought I'd do this fun one over here because we have x cubed plus x squared minus 14x minus 24. We're going to have to factor that. Do you remember how to factor that? Okay, so let's go off. I'm going to go off to a separate page. I want to factor x cubed plus x squared minus 14x minus 24. Remember what we do? We use the rational root theorem. We're trying to find factors of 24. And then we plug them back into this entire polynomial to see if we get 0. Okay, so the ones we're going to test are plus or minus all the factors of 24. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 24. And again, we don't have to test them all. Let's try plugging in 1. If we plugged in a positive 1, we get 1 plus 1 minus 14 minus 24. That's not going to work. Let's try negative 1. That would give me negative 1 cubed is negative 1 plus positive 1. And then we get plus 14 minus 24. That's not going to work. If we plug in a 2, get 8 plus 4 minus 28 minus 24. That doesn't seem to work. Let's plug in negative 2. I think negative 2 is going to work. So negative 2 cubed plus negative 2 squared minus 14 times negative 2 minus 24. That's negative 8 plus 4 plus 28 minus 24, and that in fact does give us 0. So that means that negative 2 would be a 0. Negative 2 makes this polynomial 0, which means we'll say negative 2 is a 0 of this polynomial. Therefore, x plus 2 is a factor. Okay, so what we're going to do is we're going to take this thing, x cubed plus x squared minus 14x minus 24. I'm going to divide by x plus 2. Just a reminder how to do that with synthetic division. We take the coefficients 1, 1, negative 14, negative 24, 1, 1, negative 14, negative 24. And we're dividing by x plus 2, so we put a negative 2 up here, bring down the 1. 1 times negative 2 is negative 2. Add these, negative 1. Multiply these, positive 2. Add these, negative 12. Multiply these, positive 24. And we get 0. It shows us, in fact, that plugging in a negative 2 does give us 0. Okay, and this represents x squared minus x minus 12. Okay, and when we divided this by this, we got this. So therefore, that means this thing factors into x plus 2 times x squared minus x minus 12. Let's factor that further. We've got x plus 2, x minus 4, and x plus 3. Okay, so all that just so we can factor this top part up here, which is going to be x plus 2, x minus 4, and x plus 3. The bottom is a little easier to factor. We get x plus 2, x plus 3. And then we're going to divide by, this one gives us x minus 5x plus 1. This one, I don't really like this one. The Lie coefficient is negative. So what I'm going to do is I'm going to factor out a negative 1. So negative 1 times positive x squared, then minus 2x, then minus 8. So this thing is going to factor into negative 1 times, and then that's x minus 4, x plus 2. Okay, let's state our restrictions. So x cannot equal negative 2, negative 3, positive 4, and negative 2 again. So negative 3, negative 2, positive 4. Now we can start canceling. X plus 2's, x plus 3's. Okay, so now we've got x minus 4, and instead of dividing by this, we're going to multiply by the reciprocal. So we've got x minus 4 over 1. Turn that division into multiply, and then we have to flip this fraction. So we're going to get a negative 1, x minus 4, x plus 2. And on the bottom, we get x minus 5, x plus 1. Now we have to add to our restrictions because, again, we're going to have values of x that make the denominator 0. So we're going to get a positive 5 and a negative 1. Okay. So now what we've got is, let me just double check something. Okay, so now what do we have? We've got a negative 1. We could just pull the negative out front. And we've got x minus 1, x minus 4, x plus 2. Over x minus 5 and x plus 1. Okay, let me just double check. I got something a little different when I did it last time. X plus 2, x minus 4, x plus 3, x plus 2, x plus 3. And then x minus 5, x plus 1, x minus 4, x plus 2. Oh, here's the problem. This is an x minus 4. I just rewrote that wrong. That should say x minus 4. And x minus 4 times x minus 4. So we don't have an x minus 1 and an x minus 4. What we have is x minus 4 squared. Okay, so x minus 4 times x minus 4 on the top. We've got an x minus 4 squared, and then we've got an x plus 2. Okay, so I just copied that down wrong. From here to here, that should have been x minus 4. All right, and that should be the right answer. Make sure you have that negative out front. Okay, let's go down to the bottom. Now these look intimidating. They're not. They're really not bad at all. But what you have is you have like a number and a fraction on the top, and then a number and a fraction on the bottom. So you can't use this rule of dividing fractions where you take the top and multiply by the reciprocal at the bottom. You can't do that when you have multiple terms. So what we have to do is take both of these terms, combine them into one term. So we have to get common denominators on the top. I treat this first as two separate problems. First, let's get common denominators at the top. So we've got a 4. And our common denominator on top is going to be x plus 2. So we multiply by x plus 2 over x plus 2. And then we get minus 1 over x plus 2. On the bottom, our common denominator is going to be x minus 2. So I've got 4 times x minus 2 over x minus 2. And then plus 1 over x minus 2. Okay, so now on the top, we've got 4x plus 8 over x plus 2 minus 1 over x plus 2. So now that we have common denominators, we could just take the 4x plus 8 minus 1 all over x plus 2. Okay, on the bottom, we've got 4x minus 8 over x minus 2 plus 1 over x minus 2. So we got plus 1 all over x minus 2. Okay, and then let's simplify. That's going to be 4x plus 7 over x plus 2, and then 4x minus 7 over x minus 2. Okay, let's figure out any restrictions. So x cannot equal negative 2 or positive 2. Okay, but now we've got the top 4x plus 7 over x plus 2, and we're going to multiply by x minus 2 over 4x minus 7. and nothing cancels, so that's all that we can do there. Make sure there's one more restriction. 4x minus 7 will be 0 when x is 7 over 4. So then we also have a 7 over 4. Okay. And then we'll do one more. We'll do this last one over here. So 10 plus 5 over x. Well, that's going to be the 10 gets multiplied by x over x. So we're going to get 10x plus 5 over x. On the bottom, this 10 is going to get multiplied by x squared over x squared. So we're going to get 10x squared minus 5 over x squared. Okay, running out of space a little bit. But we know that x cannot equal 0. Right now, just 0. Okay, and we're going to do 10x plus 5 over x, and then instead of dividing by this, we're going to multiply by x squared over 10x squared minus 5. Okay. Now one of the x's will cancel, but let's factor. We have to factor out, we can factor out a 5 from here. So we're going to get 5 times 2x plus 1 times x squared on the top. On the bottom, we're going to get factor out a 5 from these two terms, 5 times, then we get 2x squared minus 5, and then times an x. 5's cancel. This x cancels with one of the x's up here, so we get x times 2x plus 1, and then on the bottom we get 2x squared minus 5. And that's all we can do. We're going to have one more restriction when this thing is 0, so we would have to set, I'll just do it down here. 2x squared minus 5 equal to 0, 2x squared minus 5 equal to 0, which means 2x squared. Okay, so it's kind of messy, but that's how you would do that problem. Okay. All right. Thank you for watching, and I will see you soon.